Hey, it's Masaki from Dan's Competitive Programming Club. This week we have 6 problems. I think the later problems are a little bit easier than usual, but we'll have to see. First problem A, we're going to have n students, and then we have this point P, and every student who scored less than P points failed the exam. So we need to figure out how many are less than P. So first we need to read in the input, so read in integers, and then read in this array. And we'll have to read in n number of numbers, and then check, increment some integer, some kind of variable. So one example would be something like this, where you read into integers n and p, and then we create an array and read into the array. And then we have the number of fail counts, and then for every number in A, if this number is less than P, we increment the fail and we output the fail. So you can read into the loop and then increment within the loop as well. So you don't have to use an array, but this is just one example. Problem B, hard calculation. You're given positive integers A and B. Let's calculate A plus B in decimal. If it does not involve a carry, print easy. If it does, print hard. And these are pretty large numbers. They go up to 10 to the 18. That means it won't fit within a 32-bit integer. So if you're using C++, then you'll have to use long instead of integer. And like for Java, you'd have to use long instead of integer. So that's something to look out for. Or you can actually read in strings. So it might actually be easier to read in strings this time around. And so the example code I'm going to have is going to use strings. We're going to read in strings and then compare from the back. So we want to compare up to the number of characters that the smaller number has. So I take the minimum of the first number and the second number. So these are strings. So let's say this has, we have one with 9 characters, and then this has 10 characters. There's 1 to 9 plus 0, so there's 10 characters. So we want to do, if we're adding these two up, then we're adding up the lower 9 numbers. It's going to be the minimum of the size between the two. So I take the minimum, and then for each of the minimums, I check from the right side, just do a comparison from the end. So one easy way to do it would be to reverse both of these strings. Since strings you read from the left side, so this is index 0, this is index 0, but if you compare these two, that's not how you would add up a number, right? You would add up from the bottom. So in this case, we're actually supposed to add up from the bottom, and it turns out that there's no carry operations. But for this, you can do this instead, where you read from the back and check, subtract the character 0. So we have this character and we subtract the 0 character, and we'll get the number, the literal number for each digit, and compare. Another way to do it would be to first take the individual number of letters, number of numbers. So let's say this is 10 numbers, so 10 digits. So first, we know that the maximum is 10 digits, and then add these two numbers together, and then find the number of digits. And if there's a carry, oh wait, that might not work because the carry could be in the middle. So I think you do have to check individually for each place, which means you either have to go in maybe a while loop or something, and then keep on adding each of the smallest numbers together, and then do like divide by 10 and add, divide by 10 and add, something like that. Or you could do something like this, use a string. So either way will work for problem B. Problem C. The problem text is a little long, but basically the grandma is typing 3 times. So we'll have hello, hello, hello. And so the original text is hello, but it might be hello, 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 and it might also be a different in one of these characters. So let's say this could be different, or this could be different, or this could be different. Any number, one of the letters, possibly one of these letters, can be different. So the first thing to do is, it's guaranteed that one letter can possibly be changed to another letter, which means the character count is remaining the same. So you're always going to have these 3 groups, and you're guaranteed to have that. And we always know that the number of characters is going to be divisible by 3. So we can go ahead and split it up into 3 strings. So that's going to be the first thing to do. And one easy way to do this problem is that we know that there's only going to be a maximum of 1 character that's different. And that means that it's guaranteed that either 1 and 2 are the same string, or 2 and 3 are the same string, or 1 and 3 are the same string. So if one of these are different, then we're guaranteed that the other 2 are the same, and these are both accurate. So if you can split it into 3 strings and do some comparisons, then let's say this O is a different character, and then this and this are the same. So we can take this string and print this out, something like that. So you can just do something like that, where the most important part is to split it into 3 strings. So in C++, you might use substring. You could also just use a for loop, and then for the first n characters, you can push it into the first string. The second one, you can push it into the next one or something. It doesn't really matter how you do it, but this would be one way to do it. Just take a substring and then check if S1 is equal to S2 or S1 is equal to S3. So out of these 3 strings, we're guaranteed that either S1 is equal to S2, S1 is equal to S3, or S2 is equal to S3. So in all of these cases, we're guaranteed that these are all the cases. So if you can split it up into each of the possible cases, it does make it a little bit easier. But yeah, it's just getting used to thinking in this way. Problem D is going to be rating problems. So judges can either rate a problem 3, -3, or 0. And then at the end, we're given a floating point number of the average. And we have to output the average score. And we have K judges who've already voted, and there's some number of judges who haven't voted yet. So I have to figure that out. So first of all, we have K judges. So let's say there's K judges and there's n total judges, and K is less than or equal to n. And so you get like, there's n judges, 2, 1, and 2. And this rates the problem with an integer between -3 and 3. So the first rating was 1, the second rating was 2. So out of the 5 people, 2 people have gone. So we have like judge 1, 2, 3, 4, 5. And judge number 1 rated it a 1, judge number 2 rated it a 2. And then we don't know, and we want to get the result. Like what's the max and what's the min. So it's kind of easy to tell that the maximum that this could be is the maximum score if every person gave it a 3. And then the minimum would be if it was given a -3. So you just have to do like multiplication. This is going to be n minus k, and then you want to multiply it against ±3 and add this to the original sum. Yeah, So something like that. So the code here, I'm inputting in the score, and then I'm just adding up all the scores from the start into a single sum. And then we have the remainder of we have the number of remaining judges. And we multiply by -3. We subtract -3, subtract 3 times the remaining, or we add 3 times the remaining. And then the answer will be a floating point number, so like a double or something in C++, and we want to divide by n. What's important to note is that this minimum and maximum number is an integer, and n is also an integer. So if you just do minimum divided by n, this is just going to end up with an integer calculation. So we want to cast it to a double first, and then we want to do the calculation. And depending on the language, you might have different ways of formatting the output as well. Okay. Problem E is 1%. So we have a bank. We start with 100 yen, and everyone starts with 100 yen. 100 yen is about $1. So maybe it's around like 120 right now, I think, but it's about $1. And the bank pays an annual interest rate of 1% compounded annually, assuming that nothing other than interest rates affects Takahashi's balance. And how many years does the balance reach X yen or above for the first time? So compound interest, this is really interesting, but important to note, a fraction of less than 1 yen is discarded. So after 1 year, we add like 1% of like the current. So we have the current number, and then we add 1% of the current number. And we just keep on doing this in a while loop. And it seems easy, but you might get large numbers, so up to 10 to the 18. And then the other pitfall is that there's actually a really weird edge case that I'm going to mention as well. So E, the most standard way of solving it would be to add the current number divided by 100. This is integer division, so there's no loss in precision, and you can cut away to basically cut off to digits, and then take the rest of it and add it to the number, to the current number, and this will be 100% accurate. If you do this times 1.01, if you're adding 1%, it's the same thing as multiplying by 1.01 and then casting into long. This is good, except this is actually a double, and double precision is actually not that great, and this is almost great, this is almost correct, except there's one edge case where you don't get the expected result, and it's a hidden test case. But if you cast it to a long double literal, it turns out to pass. But it's just a lesson of how double precision floating point numbers don't really work that well with computers. And if you've done discrete math, you might know that there's something called infinite numbers, and there's large infinite and like small infinite, or smaller and larger infinites. So it's also called like countable and uncountable infinity. And so let's look at integers. Like you have natural numbers, for example, 1, 2, 3, and then like 100, 101. If you have some number, there's always a next largest number for like natural numbers or integers or something, and there's the next smallest number, something like that. So that's countable. But let's say you have a decimal number, so like we have 1.0, right? And it's just 1.0. But what's the next largest number? it's not 1.01 because it could be, you could have a smaller number. And this continues infinitely. So between even like 1 and 2, there's infinite many numbers in between 1 and 2. And so the number of like decimal numbers is really, really large in comparison to integer numbers, and it makes it really difficult when you're working with like irrational numbers, or even if it's a rational number like 1/3 and stuff like that, you're losing precision every time. So it's just a good thing to think about. Like, computers have to get rid of some of the precision, and it turns out using a double, which is around 8 bytes, is actually not enough to when you're working with these huge numbers and you need precisely 1%, then you might be off by $1 or something, and that actually could be really important for business or something. So it if it's like really far away and you're talking about like some small precision thing, it's really important. So it's a good lesson, I think. But it can be a bit frustrating. In comparison, if you divide by 100, you're just taking the integer number, which is very, very precise. It's the exact number. And then you're just removing the digits. So you're just cutting off the last 2 digits pretty much. So you're not losing any precision when you're taking 1% and cutting off and discarding a fraction. So it works out that this is going to be dividing by 100 in integer division is going to be the clearest way and a preferred way to solve this problem. Also, it might be faster as well, just because multiplication is also kind of slow with computers. Okay, problem F. There are n people numbered 1 through n in the xy plane. Person I is at coordinates x of I, y of I, and k of these people, a of 1 through k, will receive lights of the same strength. So we have a bunch of people, and let's say there's like 4 people, and then you have some kind of light, right? And another person might have a light. And when a person at coordinates x, y has a light of strength r, it lights up interior of a circle radius r centered at xy. And then find the minimum strength of the lights needed for every person to be lit by at least 1 light. And so this problem, it seems pretty complicated, and you get these like crazy numbers, right? These are really large numbers. Like, where did this come from? But you see like square root of 5, and this is actually a big hint. So let's say you have just a straight line and you have just 1%, and so let's say this is the x-axis and we have 0, 1, or 2, something like that, and this person has a light. Then we want radius of 1. We want radius of 1. And what if it was in 2 directions, but if it's really small? So you can start on like a smaller scale. And okay, so if it's x and y and it's a distance of 1, it can be radius of 1. What if there's someone here and there's only one person here? Well, then it's going to end up being that this is also going to be the minimum radius necessary. So what is this distance? And well, you can take this distance, and this is a right angle because this is an xy grid. And you can take the like y differential, and you can take the x differential, and you can just take the Pythagorean theorem, I think. A squared plus b squared equals c squared, and find the distance. So this is also called the Euclidean distance. This has showed up a couple times in our contest. It's really, really important, but the other distance would be something called like Manhattan distance. So like the number of blocks away in a city block or something would be called like Manhattan distance. And so this might be 1 block, 2 blocks away. But in this case, it's going to be 1 squared plus 1 squared, and it's going to be like square root of 2. So this is called the Euclidean distance. Euclidean distance. And yeah, so now we know if there's some person here that has a light, and this is the furthest person away, then this is going to be the distance. But what if there's multiple people, right? Multiple people with the light. And so let's say there's a person with the light here. Let's use a different color. So people with the light, there's one person with the light, another person with the light, and then you have some random people here, something. Then in this case, each person without a light can their minimum distance necessary is going to be the distance to the closest light person that possibly has a light. And the values are pretty small, so it turns out you can kind of brute force through all the combinations of people with lights and find the distance towards people with lights and find the minimum. And that's going to be the value that this person needs. And then let's say this distance is like 5 and this distance is like 6 or something. Then in the end, we need to find 6 because it's the minimum strength of lights needed for every person to be lit. And even if this is like 10 or something like that, if it's at least 6, then we know everyone's going to be lit up by the light. So we just need to iterate across. So for each person, well, let's just erase this person, and let's say there's a bunch of blue dots or something. Well, basically all you need to do is calculate the distance towards all the blue dots, all the people with lights, and find the distance to all those people and find the minimum distance, and that's all you need. All the people with lights don't really need any distance at all. They don't have a minimum radius, but yeah. So the code is going to look like, I ended up using a set just because it's a data structure that kind of combines a couple of these things and it makes it a little bit easier. So I insert have light. So A is the people who have a light. And so you can get access to, is this person lit up right now? Then I want to skip them. And then for everyone else, and then I read in the x and y coordinates. You could also read in like a vector of a pair of int or something, but that makes it unnecessarily complicated. So if you can, I would recommend having like an x vector and a y vector. If you're sorting, then you might need to combine these values together. But if you're not going to mess with the data, like the order of the data, then you can have it individually like this. So that's a good skill to have. This is going to be the easiest way to write out the x and y coordinates for every person. But if you do need to sort it in any way, like sort it for the least x values, and you want to go in order of the x values or something, then you'd have to combine the values and put it into a different structure or something and have some kind of sorting thing worked out for that. And then for each person, we have the minimum distance that they need. And again, I'm using long double. Whenever you have to use some kind of floating point number, it really doesn't hurt to be more precise. And it's just so imprecise that you kind of get paranoid. And yeah, floating point numbers really suck. But For each of these individual calculations aren't that hard, right? You have the difference in x's, you have the difference in y's, and then you have the square root of the x squared plus y squared, and this is square root L, so this is the more precise version of the square root function, which it doesn't really matter what you use, I think, but just in case. And then the minimum distance is going to be the minimum distance that it currently is compared to this current distance that you calculated. And then you want to find the max element among all these minimum distances. So the maximum out of all the minimums. So if this person only needs to go here, and then there's like another person who needs to go here, then it's going to be the maximum between this distance and this distance for every person, right? So it's going to be the max element in this array here. And then we output the answer. So it's really, there are a lot of steps to it, but what you're doing isn't that hard. What you're doing is just comparing against the other dudes, the other people with lights, and calculating distance, and these are all not that hard. Individually, all these things aren't too difficult, but the big issue is like processing all the information and make sure you're reading in everything accurately, and this is a little bit longer maybe than some of the other code, and when you start to write longer and longer programs, being organized and having a legible program, and like what do you do with edge cases? Like if you set this place to 0 at the start, then you're gonna encounter an error where you're trying to find the minimums, but the default value is 0, so you're gonna end up with 0 or something, or you end up with these weird scenarios. So you need to be careful about edge cases. You need to make sure that every step of the way that you write something, that your program is working properly, and like how can I do this in a simpler way? How can I make it easier to understand and for yourself, really? So yeah. But a really big hint, a really big hint was actually the square root here. And that's it for this contest.